the vanishing gradient problem. This was the thing that was holding back deep learning for years.
The vanishing gradient.
Look at the graph of the sigmoid function. When your input x gets very large, either positive or negative, the curve becomes almost perfectly flat.
Right, the slope goes to 0.
The slope, the derivative, goes to 0. Now remember the vector chain rule. Backpropagation works by multiplying all the derivatives from all the layers together.
Ah.
If you have a deep network and a few of your layers have activations that are in that flat part of the sigmoid, their local derivative is basically 0. So when you multiply all these numbers together in the chain, the whole product goes to 0.
The gradient just vanishes. It's like sending a message down a long line, but every person whispers it so quietly that by the end, there's just silence.
That is a perfect description. The signal dies. And that means the weights in the early layers of the network get almost no update signal. They just stop learning. And this made it practically impossible to train very deep networks. They just wouldn't improve.
So how did real you fix it?
With brute force simplicity. For any positive input, the function is just f of x equals x. The derivative of that is 1.
The constant.
A constant gradient of 1. It's not 0. So the error signal can flow backwards to the positive side of the network without getting weaker. It just passes the signal straight through. And that one simple property allowed researchers to finally train networks that were dozens, even hundreds of layers deep.
So that was the turning point. It's less about mathematical elegance and more about practical stability for training. The advice is clear: don't use sigmoid in your hidden layers anymore.
Absolutely not.